Hello everyone. I'm going to present our research in the field of unpaired image-to-image translation. To begin, I would like to discuss the problem setting. As a benchmark, we have two datasets. The first is cityscapes, which consists of records from transport in European cities. Another dataset is synthetic images from GTA 5 video game. In this case, image translation is changing the image from video game that would look like it is from photo from European city. Let's look on images. GTA has more open sky, but cityscapes have more trees and buildings instead. Most of cityscapes images have Mercedes hood ornament. Many of GTA have palms. GTA can have yellow lane lines, but its cityscapes usually have white lane lines. There are no ground truth images in training set. There are no pairs for GTA images in cityscapes. That's why translation is unpaired. Translated images must belong to cityscapes domain, but keep the individuality of original image. How to do that? Let's look at generative adversarial setting, GAN. We have generator that converts image from GTA domain into cityscapes domain. And we have a discriminator that try to distinguish if it is fake generated or real cityscape image. Both networks can use gradient from adversarial loss. Discriminator changes its weights to classify real or fake image better, but generator compete with discriminator to produce such image that will be classified as real. So they compete. If we train such network, generated image may belong to the target domain. But there is nothing to ensure that generated images have individuality or semantic of input images. One of methods for semantic consistency of translation is TraVeLGAN. Authors added third Siamese network that convert image to vector of some dimension in some hidden space. And Siamese network learns such image embedding that there is vector algebra for batches of input and translated images. It is close to language embedding like word-to-vec. Siamese network and generator cooperate together. It is cooperative learning. Generator tries to produce a batch of images that their embeddings differences are equal to embeddings differences of input images. And Siamese network learns such embedding that it proves that there is some hidden space in which generated image has individuality of input image. So, generate loss is a weighted sum of adversarial loss from discriminator and travel loss from Siamese network. A very perspective idea. We tried to experiment with TraVeLGAN. We need to choose dimensionality of hidden space, then architecture of Siamese network, loss lambda. It works, but I think it is impossible to find optimal parameters. Now I tell you about the source of intuition for our contribution. Half a year ago, casual competition Google Universal Image Embedding had a purpose to represent image with a 64-dimensional vector for image clustering. all winners and top half of leaderboard used pretrained CLIP network. It was clearly superior over all other methods. The only purpose of competition was to transform CLIP's 1000-dimensional embedding into 64-dimension without losing its properties. What is CLIP? It is contrastively language image pretraining, where text encoder and image encoder are trained together on billions of image caption pairs. They transform image and caption into common hidden space. In such way, image encoder has some knowledge transferred from natural language. It represents image in the way human describes what they see. We propose to take only the image encoder with pretrained weights and use it instead of Siamese network in TraVeLGAN setup. We need not anymore to choose architecture, dimensionality, train parameters. The network becomes much more simple to optimize results. Let's look again on our benchmark datasets. How yellow lane lines should be translated into European cityscape style? They should change color to white. But what will become with open sky? Should it change into buildings on trees? Most of previous models hallucinate trees or buildings instead of sky. It is called semantic flipping. Yellow and white lane lines are semantically the same, but tree is semantically opposite to the sky. Discriminator can count statistic and easily distinguish images with large open sky areas. That's why image translation models hallucinate buildings and trees. This problem is semantic robustness of image-to-image translation. In 2022, vector symbolic architecture was presented. It is state-of-the-art in semantically robust image-to-image translation. Let's look how our CLIPTraVeLGAN translates images. Here is image with open sky area, and it was translated with TraVeLGAN. In this case, it hallucinates cars and Mercedes hood ornament. CLIPTraVeLGAN translates images with dark sky. And there is an artifact in the sky. We increased weight of travel loss lambda, and now translation is almost correct and semantically robust. On the next picture, we can see the same. TraVeLGAN and CLIPTraVeLGAN hallucinates trees instead of open sky, but when lambda is increased, translation is semantically robust. Here we compare TraVeLGAN to the state-of-the-art model vector symbolic architecture. Both translations are semantically robust. Our proposal is not better than SOTA, but is close to it. And our method is simple and easy to implement. But our method has limitation. If we try to convert labels into European images, we have problem. Clip never saw such images while training, so we cannot help in such problem. Results are very bad. To conclude, we propose to use clip image encoder with pretrained weights instead of Siamese network in TraVeLGAN setup. We were first to utilize clip to ensure semantically robust image-to-image translation. Our method is simple and can be a step towards semantically robust image-to-image translation. We made our code available for experiments at Kaggle platform. Thanks for your attention. Questions?